Okay, so that was one case when the law is not linear. Well, there is another way of being not linear. The other way would be that someone created a new material and told you, and you pretend you are an engineer, and told you that, well, if you use that material is governed by the law delta L is K times F times L squared. It's not Hooke's law. And you don't want it to be Hooke's law. It's created intentionally to satisfy that beautiful law. So if you have, well, a spring satisfying that law, what would be the length? So if that happens, and you proceed with the same argument, you have delta x squared there, and you have delta x squared. Is it linear on delta x? Well, you can still pull delta x out, so it is delta x times something, but unfortunately that something has a term delta x inside. So in that case, I'm back to the formula 1 plus something times delta x, but that something contains delta x. So can we get something out of it? Or can we look at the limit and see what happens without rushing to the integral? What about this limit? Well, again, the first part has no problem. It's something about the second part. Let's look at the simple limit. Limit as delta x goes to 0 of the quantities sum, right? Sum over all i's of delta x squared. So what I'm doing here is I'm taking a fixed length and I'm subdividing, and every time I subdivide, I take squares of those small lengths, add them up. And as I subdivide, I get more and more terms, but those terms become smaller. So there is a hope I have a limit. What kind of limit is that? So let's do a simple computation. Let's pretend this is from 0 to 1. And then if there is no subdivision and my delta x is equal to 1, if delta x equals 1, what is the sum? The sum is 1 squared, which is 1. So put the values of sum in the column here. Now if delta x equals a half, I subdivide into 2 halves. What's going to be the sum? I have 1 half squared plus 1 half squared. A quarter plus a quarter, so it's a half. And then delta x equals a quarter. So I subdivide further. What's the sum? It is the sum of 4 things, and each thing is what? 1/16. So it is a quarter. And if delta x equals 1 over 8, so I subdivide it one more time. I have 8 elements, each 1 over 64, so it's 1 over 8. Can you guess now what the sequence is going to be? Do you know what the limit is of the sequence 1, a half, quarter, 1 over 8? Isn't it? 0. So that's 0 without even doing any integration. So what's the consequence? Well, the consequence is that for that beautiful material, if you hang it like that, it doesn't stretch. It keeps the same length. Well, that is something you can verify. You request a sample of material, you hold it, and you watch what happens. And if that matches your computation, well then it's fine. But if not, then maybe this process of integration doesn't apply for some reason. And why wouldn't it apply? What can be wrong? Because you were told this is the law. That's how that guy coming to you, material scientist, that's how he discovered the material. So if that law holds, what can be bad about the whole story? There is one thing left, right? Additivity. You really have to think about that material. Well, do we expect additivity to happen? Well, is additivity related to material at all in this problem? Probably not, right? You subdivide and you expect the length to be sum of lengths. So additivity holds. What does that mean? Does it mean it's impossible to make a material like that? What does it mean? I don't know. Because there are all kind of laws one can imagine, right? L cubed, L to the power 4, square root of L, right? Why are we using only one law called Hooke's law and not Hooke's squared law, not square root of Hooke law? Is it because those never happen in nature? Or because we ignore them for some reason? And I don't know. It's your turn to explore. I know only one law. It doesn't mean that applies at every single situation, but... Alright, so sometimes it works, sometimes it doesn't. And what we learn in this course is ability to recognize quickly how, when, and why integration works or doesn't work.